Welcome to today's math lesson. Today we're going to be identifying proportional and non-proportional relationships from different verbal descriptions or situations. Our do now reads, Melanie and Patrick have different phone services. The relationship of the monthly cost $Y to send or receive X text messages is a linear function. The cost of Patrick's texting is described by Y is equal to 0.03x plus 5, or 3 cents per text message plus a base cost or an initial cost of $5. The cost of Melanie's texting is shown in the table. We have to write an equation to represent Melanie's monthly texting costs. So when we're given a table, we can't easily identify whether a relationship is going to be proportional or non-proportional. So what we're going to do is assume that it's non-proportional and use our slope equation. So we have M is equal to Y2 minus Y1 over X2 minus X1. Then we're going to choose 2 points from the table. We're going to label them X1, Y1, X2, Y2, and then we're going to find the slope of them. So I'm just going to choose the first 2 points in the table. So 5, I'm going to label X1. $1.25, I'm going to label Y1. 10, I'm going to label X2. And $2.50, I'm going to label Y2. So from here, I'm just going to plug in the numbers into the slope formula and subtract. So Y2 is $2.50 minus Y1, which was $1.25, divided by X2 is 10, X1 is 5. So then we have $2.50 minus $1.25, which leaves us $1.25 or 1.25. And then we have 10 minus 5, which is 5. From here, we're going to divide. $1.25 divided by 5 is going to be 0.25. So from here, we're going to assume that since this is a non-proportional relationship, the equation that we're writing the slope into is Y is equal to mx plus b. So our slope is the 0.25 or 25 cents. So I have Y is equal to 0.25 x plus b. So from the 2 points that we had originally used to find the slope, I'm going to use one of the points to find our y-intercept. So you can use any point, but I'm just going to use the first point here. And instead of y is equal to 0.25x plus b, I'm going to plug in the y, which was 1.25, is equal to 0.25. X is 5. So I'm going to multiply 0.25 times 5, and then I'm going to add b to it. So we have 1.25 is equal to 0.25 times 5 is 1.25 plus b. And then from here, I see that 1.25 is currently positive. To solve for b, I'm going to subtract 1.25 on both sides. $1.25 minus 1.25 is 0. So on this side, it'll cross out, and we're left with b is 0. If b is 0, that means our y-intercept is at our origin. So now we're writing the equation for Melanie's monthly texting cost. So y represents the total cost is equal to 0.25x. And then the second question is asking which service, or it should be whose service, is cheaper when 50 texts are sent and received in 1 month. So for Melanie, the equation is y is equal to 0.25x. And if x represents the number of text messages, we're going to do 0.25 times 50. which gives us $12.50. And then for Patrick's texting cost, we're using the equation y is equal to 0.03 times x plus 5. So we have 0.03 times 50 plus 5. And then we get $6.50 or 6.5. So we can clearly identify that Melanie's service is more expensive and Patrick's service is cheaper. Today's TEK is 8.5H. Our lesson target is that scholars will identify examples of proportional and non-proportional functions that arise from math and real-world problems, and our deal well is given 4 problems. Scholars will identify examples of proportional and non-proportional functions that arise from math and real-world problems with 100% accuracy. Some review vocab words are proportional and non-proportional. So proportional relationships are always written in the form y is equal to k times x, and non-proportional relationships, at least linear relationships, are written as y is equal to mx plus b. And we can distinguish or tell the difference between proportional and non-proportional relationships. They're both straight lines, but one of them has a y-intercept, and that is not the origin, and that is non-proportional equations. And then proportional equations or relationships have a y-intercept that goes through the origin. Linear just means straight line. Rate of change can describe either the constant of proportionality or the slope. It's basically just a change in y over the change in x. For non-proportional relationships, the y-intercept can be identified the letter B is used to represent the y-intercept. Function is the same thing as an equation. There's a y value for every x value, and origin is the point 0, 0. This first I do reads, which situation represents a proportional relationship? So I know that proportional relationships, at least linear proportional relationships, are written as k over y over x. K is equal to y over x is going to be our equation for our constant, but our equation is going to be y is equal to k times x. So I'm going to go through each of the answer choices and try to write an equation for each one and see which one is a proportional equation. So answer choice A says the cost of purchasing a basket of apples for 98 cents per pound plus $3. So the equation for this situation would be y is equal to 0.98 times x, with x representing the number of pounds of apples, and then plus 3. So it's not going to be A because this clearly has a y-intercept of 3. For B, it says the cost of purchasing plums is $7 per box of peaches with a delivery charge of $3. So this equation is going to be y is equal to 7, and per is the key word to tell you that the 7 is the slope, so 7x. And if there's a delivery charge of $3, then we're adding on $3 to the total cost of purchasing the plums. So we're going to add 3. In this case, the y-intercept is also 3, so this is not a proportional relationship. It's non-proportional. C says the cost of purchasing grapes for $1.80 with a coupon for $1 off the total cost. So our equation is y is equal to, we have 1.80, and there's no keyword to tell us that it's $1.80 per pound or anything like that. So I'm just going to have $1.80, and if we have a coupon for $1 off, that means that we're subtracting $1 from the total cost with y representing the total cost. So in this case, we have $1.80 minus 1, which would just simplify to y is equal to 0.80. And that doesn't look like a proportional relationship. And our last option is the cost of purchasing apples for $1.85 per pound plus a shipping fee of 20 cents per pound. So per is the key word to tell us that the number that's in front of it is our slope. And in this case, we have two numbers that are potentially our slope. So we're going to write out our equation, y is equal to, then we have 1.85x, because x represents the number of pounds of apples. And then it says plus a shipping fee, so plus 20 cents per pound. So then we have 0.20 x again. And so both numbers have a variable of x attached to it. And so these are called like terms. And we're going to combine like terms by adding them together. So if we add together $1.85 plus 20 cents, we get $2.05 or 2.05 x. And so when we simplified, when we added the like terms, we now have an equation that looks more similar to a proportional relationship equation, since it is y is equal to 2.5x or 2.05x. So it's $2.05 times x. For the second IG problem, it reads, Marta, a whale calf in an aquarium, is fed a special milk formula. Her handler uses a graph to track the number of gallons of formula, Y, the calf drinks in X hours. We have to figure out if the relationship between X and Y is linear, and then we have to figure out if it's proportional. So looking at this graph right here, if we drew a line through the dots, we could see that it's a straight line, so it is linear. And because it's linear, we know that we can either use the equation y is equal to k times x or y is equal to mx plus b. And now we have to figure out whether it's proportional. So proportional relationships are linear equations that go through the origin. And in this case, we have a point at the origin. So we also know that this relationship is proportional. And that the equation, once we figured out what the constant of proportionality is, would probably be in the form y is equal to kx. So now it's time to complete your 4-question DOL in Google Forms. Thank you so much for following along in today's lesson, and see you in the next math video.